Periodic table trends. These are general patterns followed by the elements. We're going to focus on atomic radius, electronegativity, and ionization energy. First, atomic radius. This is half the distance between the nuclei of identical atoms that are bonded together. When you travel down each group or family, the atomic radius increases. This is because each step down adds a new level to the electron cloud, making a larger atom. From left to right or across the period, the atomic radius decreases. This is because more protons in the nucleus creates a stronger pull on the electrons, forming a tighter atom. The key element in this trend is francium, also known as fat Francis. Francium has the largest atomic radius. So here's a trick. The further away from francium an element is, the smaller its atomic radius. Now let's move on to electronegativity. This is the ability of an atom to attract electrons. The scale to measure this ranges from 0, the lowest, to 4, the highest. Generally, electronegativity increases as you travel across the periods or from left to right. This is because metals are on the left and they tend to give off electrons, making them have a low electronegativity. As you move down each group, the electronegativity either decreases or does sometimes remain the same due to the similar characteristics shared by the atoms in the same group or family. This trend also has a trick. Fluorine, also known as fancy fluorine, has an electronegativity of 4, the highest possible one. So the further away from fluorine, the lower the electronegativity. And last but not least is ionization energy. This is the minimum amount of energy needed to remove the highest energy electron from an atom. This trend is the opposite of atomic radius but follows the same pattern as electronegativity. Therefore, across the periods, the needed ionization energy increases. And as you travel down the groups and families, it decreases. This is because the larger the atom, the easier it is to remove its electrons. Also, the more electrons being removed, the more energy you need to remove them. There's not a trick for this trend, but if you can remember electronegativity, the pattern works the same way. Here's a summary that shows all of the trends.